So in this video, I'm going to show you the steps that you need to take the derivative of a function at a specific point, or find the slope of the tangent line at a specific point. Unfortunately, I haven't found a way to show the lesson at the same time as showing the calculator. So hopefully you can have the lesson out in front of you. This is lesson 2.3, estimating derivatives, and follow along on there. So the first question asks to find the derivative of the sine of square root of x with respect to x at x equals 2. So in order to do these kinds of questions, you're going to need a few different buttons on your calculator. One of them is this funny curl thing that shows up there. So that's going to be your right shift cos button. You're also going to need, this is just your regular x variable button. You're going to need this bar button up here. So that's the right shift tool button. You're going to need the equals button, so the right shift W button. And what else are we going to need? X, sine, square root. I think all the rest of them should be pretty straightforward. So those are the buttons that we're going to be needing. So make sure that you've located them, because it's not easy for me to show you later on where the buttons are that I'm looking at. Okay, so in order to find the derivative, I'm going to use my right shift with the orange shift and that funny curl. So this is telling me I want to find the derivative of something. And then I'm going to put the x. This is saying the derivative with respect to x. Oh, another button that we're going to need is also these parentheses here. They come in handy a couple times. So you're going to need those as well. So then I'm going to put in, I want the derivative with respect to x. I'm using my x button. Then I'm going to use my left shift, the white shift parentheses. Everything in parentheses is what I'm going to take the derivative of. And then I'm going to type in my function. So sine of square root of x. Type that in. That's what I'm going to take the derivative of. And then I'm going to move out of there. And this is where I'm going to use that straight line button that was your right shift tool. Is this right shift tool again up here is going to let me evaluate at a specific point. So put that one in. I have to left over one so that I'm writing after that button. And then I'm going to use my x. I want to evaluate at x equals. So right shift till I get that equals, and right shift x equals 2. So this is, I'm taking the derivative of the sine of the square root of x and evaluating it at x equals 2. If I hit enter, it's telling me that I did something wrong. Oh, right. Sorry, forgot this step. I do need parentheses around that part. So left shift parentheses, I put in again x equals 2. Try that. If we hit enter, it gives me the exact expression for that derivative evaluated at x equals 2. So if I want to actually get a numerical approximation, the decimal number, I'm going to go right shift, which is the orange shift, and then the enter button, the orange says num. So if you're looking up here, right down here, that's what I'm looking for. I want that num. And so that's going to say, okay, yes, I want to take the last answer that I had, and I want it to get me a numerical approximation. So if I hit enter, there it is. That's the slope that I'm looking for, and it's in scientific notation, remember. So I need to change that into decimal notation and round to 3 decimals, or truncate to 3 decimals. So in this case, it would be 0.055 would be my decimal approximation. So that was the derivative of sine the square root of x evaluated at x equals 2. You may need to go back and try that yourself. Watch the video again, pause it, because there's quite a few steps going on there. I found it a little bit confusing to learn it myself. So hopefully once you've got it figured out, then it won't be a big deal to be able to do it when you need it. So that was the first question for 2.3. The second question asks me to find the derivative of the natural log of 1 over 5 minus x at the point 1.3. So let's see if I can type that into my calculator. So again, it's going to be orange shift, right shift, that funny curl. That funny, it's kind of like a D for derivative, partial derivative. I'm going to put in my x. Then I need my left shift, right shift parentheses, and in here I'm going to type in the equation or the thing that I'm going to take the derivative of. So I need to find on my calculator the natural log function. Should look that up ahead of time. Give me 1 second. Okay, found it. It is up here above my y to the power of, looks like. So I'm going to use the orange shift natural log function. So there we go. Then it's the natural log of 1 divided by 5 minus x. I'm going to put parentheses around that part as well. So left shift parentheses 5 minus x. That's my whole function. And let's see if I got everything in there that I need. I think so. Close all the right parentheses. Get to the end here. I'm going to do the orange shift pipe or the tool up above the tool. That's the one I need. Again, white shift, left shift parentheses, and I'm going to tell it I want it to be at x equals 1.3. A lot of steps. Sorry about that. Your calculator is not the most straightforward, but hopefully you can follow along, watch this video a couple times until you've got it down. Hit enter, gives me an exact solution, so that's fine if you like that. Or again, orange shift, right shift, num, hit enter, and it gives me the decimal approximation. And I'm going to use that, write down 0.270. That would be to 3 decimal places. Would be the answer that I'm looking for number 2. Okay, one more on the calculator, and that is number 3 says, write the equation of the line tangent to y equals square root of x over x cubed plus 1 at x equals 1. So in order to find the equation of the tangent line, I'm going to use my calculator to find the slope of the tangent line, which is the derivative at the point x equals 1. So again, right shift, orange shift to get that derivative button, that funny curl, it kind of looks like a D. Again, put that x in there. I want the derivative with respect to x. Need parentheses, so white shift parentheses, and then I need to type in my equation, which is square root of, I'm going to put parentheses in again, so I know I'm taking the square root of everything here, x divided by, and then everything on the bottom, I'm also going to put in parentheses. These are a lot of parentheses. Fortunately for me, it gives me both at the same time. So x to the power of 3 plus 1. Okay, so that's my expression. Get all the way out here. Orange shift, right shift, tool, to get that pipeline. Left shift or white shift, get more parentheses, and then I want to tell it to evaluate at x equals 3 at x equals 1. Hit enter, and it gives me a huge, big, long expression. What I really want is a numerical approximation. So orange shift, right shift, num, hit enter, and there it is. That is the slope of my tangent line that I need for this equation. So that's going to go in the space for slope. And then I also need to evaluate the expression itself at x equals 1. So you can do that by hand if you want. Square root of 1 over 1 cubed plus 1 is the square root of a half. And I can get a decimal approximation for that, square root of 0.5. There's my decimal approximation. And then to write this out, remember it's y minus f at a. So what I just found is 0.707 is f of a. So y minus 0.707 equals the slope, or f prime at a, which is what I found, which is the derivative. So negative 0.177 or 176, depending on if you round or truncate, times x minus a, so times x minus 1. And that's a little bit hard for you to picture. Go ahead and watch one of the videos where they use a different calculator, because what your final answer is going to be is actually relevant no matter what kind of calculator you use. It's just on your calculator following the steps in order to get this negative 0.177 or 176 as your slope. So that's the last example of finding the derivative of a point. Again, you may need to watch this video several times and practice the set of steps so that you're confident to do this in the future on your calculator. Hope that makes sense. Let me know if you have any more questions or get